6.4, volume about a line. Find the volume of the solid region generated if the region is revolved about the given line. To rotate about a horizontal line, y equals c, express the radius of the outer and the radius of the inner as functions of x and integrate along the x-axis. So example number 1, we have the function y equals the square root of x. We have y equals 0, x equals 4, and so this region right here is the region that we are revolving about this line y equals 4. Okay? So perpendicular to the axis of rotation, we will have our little r, because we see that this is going to be a washer, so washer method, and we have our big R. So we are going to be using the washer method because when we rotate this region about the line y equals 4, we do end up with a washer type situation where there's a hole inside. So now, outer radius is just 4 because it is from this point to this point, and that would be 4. Inner radius, notice that this is, if I picked a point here, this region right here is the y value of that point. And did you notice that this was delta x for both of these little rectangles here? So we are going to be integrating in terms of x. But notice that this is the y value of the function. The part we need is 4 minus that y value. So this is going to be 4 minus the square root of x, because our y value for that function was the square root of x. We said we were going to use the washer method. So let's get busy trying to calculate our area. We said it was x integration, so this is integrating from 0 to 4, pi big R squared minus pi little r squared dx. Integration from 0 to 4, pi 4 squared for our big R, outer radius, minus pi 4 minus the square root of x squared dx. Bring your pi out in front. 16 minus, we're going to go ahead and square this. 16 minus 8 root x plus x dx. So now 16, now let's distribute that negative. So the 16s cancel. We've got 8 root x minus x dx. Now integrate. X to the 1/2 plus 2/2 is x to the 3/2. And then we are going to multiply by 2/3, because divided by 3/2 is multiplication by 2/3. Minus 1/2 x squared from 0 to 4. So this is going to be 16/3 x to the 3/2 minus 1/2 x squared from 0 to 4. (16/3) times, and remember, this denominator means square root. So we've got square root of 4 to the 3rd power minus 4 squared. When I put the 0 in, I'm going to get 0. So I'm just going to go ahead and stop there. So we've got 16/3 times 2 cubed minus, this is going to be 16 divided by 2, which is 8. So I have 8 times 16 over 3. That's going to give me 128 over 3 minus 8. And this will give me 128 over 3 minus 24 thirds, 104 pi over 3 units cubed. Okay, so let's look at the next one. Example number 2 gives us y equals 4 minus x squared, y equals 0, and it's about the line y equals negative 1. So I'm going to go ahead and sketch this. So 4 minus x squared this is y equals 4 minus x squared, and that's 4. And then we've got y equals 0. And so we're talking about this region right here. And we are going to rotate it about the line y equals negative 1. This is again a washer method problem. And if we were going to sketch from our axis of rotation to here would be little r, axis of rotation to here is our big R. So our outer radius, remember if you were imagining that this point is a point on that function, look at what the y value of that point would be. We're going to have to add 1 to it. This is a distance. Even though this is negative 1, we're adding 1 to it because it's a distance. So for that, we've got our 4 minus x squared, but we're adding 1. So I'm going to take my positive 4 and my positive 1. This is going to be 5 minus x squared as our outer radius. Our inner radius. So if we've got this, what is that? The whole way across. For that whole time that you're going across, it is always just a distance of 1. So if that is a distance of 1, that inner radius is going to be 1. This is washer method. I'm just erasing this so we can do our next problem. I know you guys probably already have all this written down. It's just not erasing as fast as I want it to. Okay, so volume. Did you notice that this was delta x? The thickness was delta x. So now, did you also notice that there is symmetry here? So we are going to use symmetry on this, because I know if I integrated from 0 to, well, we have to figure out what this is. Okay, this is on your y equals 0. So 0 equals 4 minus x squared. So if I move my x squared over, square root of both sides, x equals plus or minus 2. So we are going to integrate from 0 to 2, but then we're going to multiply that by 2 because we're using symmetry. So I kind of squished it in there, so I'm going to erase that so I can move it over. V equals twice the integration from 0 to 2. And this is going to be pi big R, which we said was 5 minus x squared squared minus pi little times little r squared, which is 1 squared dx. We're going to bring the pi out front. We're going to multiply 25 minus 10x squared plus x to the 4th minus 1. 25 minus 1 is 24 minus 10x squared plus x to the 4th dx. Now we're going to integrate 24x minus 10 thirds x cubed plus 1/5 x to the 5th from 0 to 2. So 24 times 2 minus 10 thirds times 2 cubed plus 1/5 times 2 to the 5th, and then minus 0 would give us 0. 48 minus 80 thirds plus 32 fifths. And this gives me 416 over 15, 832 pi over 15 units cubed. Okay, now to rotate about a horizontal line, that's supposed to say vertical. To rotate about a vertical line, x equals c, express the radius of the outer and the radius of the inner as functions of y and integrate along the y-axis. Okay, so now let's look at this example. Y equals x squared. Y equals 4. And about x equals 3. So this region right here is the region that's bounded by those first two functions. And we are rotating it about the line x equals 3. So now this time, from the axis of rotation to the first part of the function is our little r, and from the axis of rotation to the very farthest part of the function that we are rotating is our big R. You can see that if we made that like a representative rectangle, that distance would be along the y-axis delta y. We know that our axis of rotation is y. I mean, not axis of rotation. Our integration will be y integration. Okay, so our outer radius. Let's think about if we picked a point on the function. Okay, let's see. I'm going to pick a point in pink. If we picked a point on the function and we imagined okay, so this would be x and this would be y. So this is the x part of the function, and Then we've got another one of those, right? And they're equal. And then we've got what else? Well, what else do we have there? How are we going to figure this out? So the x part of our function, y equals x squared square root, x equals the square root of y. We've got two square roots of y there. I guess I shouldn't have said equals x because, come on, because that is just this piece, you know, those two pieces right there. Now we've got this piece right here. So what is that going to be? How are we going to figure that out? Because this one is x equals 3. Okay? So from here to here, how are we going to figure out what that distance is? If we're spinning it, you know, it's only really the region from 0 to 4, and we're rotating it about that line, x equals 3. How are we going to figure out what that is?